projects can be broadly represented in two modes, the activity on arc mode and the activity on node mode. The activity on arc mode is popularly referred to as an arrow diagram also, and in fact these calculations are generally event oriented calculations based on the because in this AOA representation what happens is that each activity is represented on the arrow, and the starting node and the end node of each activity is given the interpretation of an event. So it is a point of occurrence in time, and therefore these algorithms which are there on AOA networks are often referred to as event oriented algorithms. On the contrary, when you refer to an activity on node network, these networks in common parlance are also known as precedence networks, and the kind of algorithms which are used for scheduling here are typically referred to as activity oriented networks, because each node on the network is now representing an activity and it is not representing a point in time or a milestone as it was in the AOA network AMPO. And let us take an example which has the predecessors for each of these jobs is identified as shown in this list, and we are assuming that for each of these jobs we have estimates of the duration of the job in days, and these estimates are given here in this particular list. And the objective of the analysis or the basic scheduling computations is to establish a time schedule for various activities and to find out when this project can be accomplished at the earliest. This is the broad intention of the whole analysis. So the first step in doing this problem is to represent this information on jobs and predecessors in the form of an AOA network, and this can be done very conveniently by means of a diagram which would, if you look at the list, which would be something like this. You notice, for instance, in this particular diagram that the activities are shown here. This is activity A, activity B. If you notice from the precedence relationships of the various jobs, then you would have noticed that if you look at the precedence relationships of the jobs, A and B had no predecessors, so they are starting from a source node. C has predecessor A as shown here, but activity D has predecessors both A and B. So what we need is, we need to add a dummy activity from here to here, showing that activity D now has predecessors both A and B as per the requirements. Then we talk about activity E. Activity E has predecessor D as shown here. Activity F also has predecessor D, so activity F is shown here. Then activities G and H, they both have predecessors C and E, so C and E are the predecessors for both G and H as shown here. And as far as activity I is concerned, it has three predecessors, namely F, G and H. So what we can do is, we can bring a dummy arc from here and show it like this, and then for activity I we have F, G and H are all shown as predecessors for activity I. Now a comment on this particular network is in order. You would recall that when we were talking about various dummies, we can identify in this particular case that we have used two dummies. You may call them D1 and D2. Notice that D1 is a logical dummy, and what is the nature of the dummy D2? It is not a logical dummy. but it is a dummy which is necessitated by the fact that activities G and H are in parallel, and therefore for uniqueness of activity representation I have had to introduce this particular dummy D2. So these are the two dummies which have been introduced in this particular network, and we have indicated here the activity durations adjacent to the arcs. Notice that in the AOA representation it is the arcs which represent the activities, so the durations of the activities are shown adjacent to the arcs.